We're now going to look at the factor theorem and the remainder theorem. Let's tackle the factor theorem first. You're already familiar with this idea. If one number divides exactly into a second number, then that number is a factor of the second number. So for example, 35 divided by 7 is equal to 5. Therefore 7 must be a factor of 35. A similar thing happens in algebra. The factor theorem is a really useful tool, and it allows you to find factors of polynomials of any order, provided the polynomial factorizes. Let's take a simple example. A simple quadratic function can be factorized by inspection. For example, f of x is equal to x squared plus 2x minus 3, which factorizes to be x minus 1, x plus 3. Thus, the roots of this quadratic are x is equal to 1 and x is equal to negative 3. What happens if we substitute these values back into the quadratic? If we substitute in x is equal to 1, we get 1 plus 2 minus 3, which equals 0. Substituting in negative 3 into the quadratic gives you 9, take away 6, take away 3, which also equals 0. Reversing this process enables us to factorize cubics and polynomials of higher degrees. Let's take a simple example. I have a cubic where f of x equals x cubed plus 7x squared plus 9x plus 3. If I substitute in x is equal to negative 1 into the cubic, I get negative 1 for the x cubed, plus 7 for the 7x squared, minus 9 for the 9x, plus 3, which gives me 0. Substituting in negative 1 gave me 0. This implies that x plus 1 is a factor. Notice the change of sign. I substituted in negative 1, therefore plus 1 is my factor. For a polynomial function f of x, the factor theorem says that if f of a is equal to 0, then x minus a is a factor. Let's look at a question. Show that x minus 2 is a factor of x cubed minus 3x squared minus 4x plus 12 and fully factorize the expression. I could perform long division, and provided there were no remainders, it would prove that x minus 2 is a factor. However, if we substitute in plus 2 into the cubic, 2 cubed minus 3 2 squared minus 4 times 2 plus 12 gives me 8 minus 12 minus 8 plus 12, which equals 0. Hence, x minus 2 is a factor. The possible other factors are x could be plus or minus 1, x plus 2, x plus or minus 3, x plus or minus 4, x plus or minus 6, x plus or minus 12. These numbers have been selected because they are all factors of 12, which is the constant in the cubic. As this is a cubic expression, and I've already found a linear factor, x minus 2, the other factor has to be a quadratic. Let's substitute in plus 1 into the cubic. I get 1 minus 3 minus 4 plus 12, which does not equal 0. Hence, x minus 1 is not a factor. Let's substitute in negative 1. This time I get negative 1 minus 3 plus 4 plus 12. That does not equal 0. Therefore, x plus 1 is not a factor. Let's try substituting in negative 2. I get negative 8 minus 12 plus 8 plus 12, which equals 0. Therefore, x plus 2 is a factor. Let's try substituting in x is equal to 3. I get 27 minus 27 minus 12 plus 12, which equals 0. Hence, x minus 3 is a factor. Putting that all together, x cubed minus 3x squared minus 4x plus 12 is equal to x minus 2, x plus 2, x minus 3. And my cubic has now been fully factorized. You can use factor theorem to find one factor and then long division to find the others. Let's fully factorize x cubed plus x squared plus x minus 3. I'm going to substitute in 1 and I get 1 plus 1 plus 1, take away 3 is equal to 0, therefore x minus 1 is a factor. Using long division, I then get my quotient to be x squared plus 2x plus 3. Just looking at this quotient in a little bit more detail, a is equal to 1, b is equal to 2, c is equal to 3. b squared minus 4ac gives me 4 minus 12, which is negative 8. And as you know, since b squared minus 4ac is less than 0, there are no real roots to this quadratic, which means it cannot be factorized. Therefore, x cubed plus x squared plus x minus 3, when factorized, is x minus 1, x squared plus 2x plus 3. Here is a question for you to do. Using the factor theorem, find the factors of f of x, which is equal to x cubed minus 2x squared minus 5x plus 6, and hence factorize fully. Pause the video and work through this question. Then set play to check your solution. I tested mine using 3. You may have used another value, negative 2 or plus 1. Either way, once you've fully factorized it, you should get the same results as myself. So x cubed minus 2x squared minus 5x plus 6 factorizes to x minus 3, x plus 2, x minus 1. Here are 3 questions for you to factorize fully. X cubed plus 7x squared plus 14x plus 8 is question 1. Question 2, x cubed plus 7x squared plus 16x plus 12. And question 3, x cubed minus 2x squared plus 2x minus 4. Pause the video, work out all 3 questions, and when you're ready, press play to check your solutions. Remember, I may have used another value to substitute in when using the factor theorem, but your final answer should be the same as mine. So, for question 1, x cubed plus 7x squared plus 14x plus 8 factorizes to x plus 1, x plus 2, x plus 4. X cubed plus 7x squared plus 16x plus 12 factorizes to x plus 2, x plus 2, x plus 3. And finally, x cubed minus 2x squared plus 2x minus 4 factorizes to x minus 2, x squared plus 2. Let's now look at the remainder theorem. The remainder theorem gives a quick way of finding remainders without the need to carry out long divisions. Note, the remainder must always be smaller than the divisor. Why? Because if the remainder is larger, it means the divisor can still divide into it. Using long division, find the remainder when 2x cubed plus x minus 7 is divided by x plus 2. Pause the video, work through this practicing your skills of long division, and then when you're ready, press play to check your solution. How do we get on? The quotient is 2x squared minus 4x plus 9, and clearly the remainder is negative 25. The divisor was x plus 2. So if we substitute in negative 2 into the cubic, we should get a remainder of negative 25. As you can see, I've substituted x is equal to negative 2 into the cubic expression of 2x cubed plus x minus 7. I get negative 16 minus 2 minus 7, which gives me negative 25. The remainder theorem states that for a polynomial f of x, if f of x is divided by x minus a, then the remainder is f of a. Here are two questions for you to have a go at. Number 1. When the expression x cubed plus ax squared plus 3x minus 5 is divided by x minus 2, it has a remainder of negative 3. Find the value of a. Question 2. Find the values of a and b if x to the power of 4 plus ax cubed plus bx squared minus 2x plus 8 has a remainder of 6 when divided by x minus 1 and a remainder of negative 24 when divided by x plus 2. For question 2, there's a small hint. You might want to use simultaneous equations. Press pause on the video, have a go at both questions, and then press play to check your answer. For question 1, a was equal to negative 3. For question 2, b was equal to negative 5 and a was equal to 4. We have now looked at the division of polynomials, factor theorem and remainder theorem. Make sure you are familiar with all three as we will be tackling questions in class. We shall also look at division of polynomials by comparing coefficients. It is really important that you are familiar with all of 3 lessons, with all 2 lessons. See you guys on Tuesday.